when solving a question, well, really what we're doing here is we're just trying to write this in a certain form so that I can see the vertex and P and all that stuff so I can get the equation so it would be able to graph it. I'm going to distribute. I'm going to multiply together. I'm not going to distribute the 1/16 though. I'm going to FOIL the rest of it together first. So you're going to say y equals 1/16 times, that's going to be x squared minus 2x minus 48. I'm going to do this. At this point, I can FOIL, or I can distribute the 1/16, but I realize that if I do that, I'm going to end up having to factor it back out. Right? So the only thing I really need to do is to take the 48 and get it over the other side. So we would do that is I need to multiply the 48 times the 1/16. So what is 48 divided by 16? 3. Okay? So what we're really going to do is we're going to just add 3 to both sides. Okay? If you want to multiply through and then add the 3 and then factor out the 1/16 again, it's not a problem. It's just a couple extra steps. Okay, so we're going to end up with y plus 3 on this side equals 1/16 times x squared minus 2x. If you do what I said earlier, if you do kind of work all that out, you'll come out with the same exact scenario as we have here. At this point, we're going to complete the square. That's kind of the entire exercise. When you do this with a parabola, this is what usually happens, right? These forms in 5 and 6 on that worksheet are essentially the ones that are a little bit unusual. The 7, 8, 9, and 10 are a little bit more kind of a consistent, more expected kind of form. So we're going to go ahead and do this. Remember, b over 2 squared, this is the key to unlocking how to do completing the square. So I'm going to take b, which in this case is -2. So -2 over 2 squared, which is -1 squared. That means I'm going to add 1 here. But I'm not really adding 1, right? Whenever you add something inside parentheses, in order to add it to the other side, just like we did with the 3, I have to multiply that number times the whatever factor outside there is. And so we'll end up taking the 1 here and multiply it times the 1/16 and adding that number to the other side. Yes, that's going to give me a fraction. It's okay. We're just going to deal with it. Okay. How do you write 3 as a 16th, right? So we end up with y plus 3 plus 1/16. Good, right? That's like 3 over 1. So that's, and we kind of already did this. It was 48/16. Like it was earlier. So if we say 48 over 16 plus 1 over 16, that's going to give us the y plus 49 over 16. That's ugly, and we're just going to leave it alone. It's not going to impact anything. We're just going to leave it there. You could leave it as a 3 and 1/16 as well. Suppose you could even write the decimal if you really wanted to. Wouldn't make a big deal of either one of those. So I'm going to go ahead and rewrite this one as y plus 49/16 equals 1/16. Now here comes, I always 100% of the time do the completing the square with this little step involved because I want to see the number right before I squared it. If I know this number, I already know how to factor it. And so we're going to write that down as x plus 1 because -1 because I squared -1 to get that value. Right? The way you do this, you look at the variable you were working with and the number you squared, and you're going to take those two things, you're going to put them together right here every single time. So this part going from the big piece here to its factored form, generally speaking, is a very easy thing to do because you kind of did it on purpose. So it should happen that way all the time. Okay? The next step is really to, we usually keep the number on this side. So we're going to multiply by the reciprocal, right? So 16 over 1 on both sides. So that leaves me with 16 times y plus 49 over 16 equals x minus 1 squared. And I would consider this one relatively difficult. Okay? So if you get that, doing it in a traditional sense should be pretty straightforward. We're going to look at number 9 next, and we're going to kind of deal with the negative 11 thing first. So the problem is negative 11 squared minus 110x plus y minus 271 equals 0. So one of the things that I really try to make sure happens first is that I keep the term with x squared as a positive value. So rather than adding or subtracting the y and the negative 271, I'm going to add the negative x squared and the negative 110x to the other side to make those values positive, right? So we end up with y minus 271 equals 11x squared plus 110x, right? We just added those two values to the other side just to get them to move over. At that point, it becomes a little bit easier to work with. Obviously, 11 can be factored out really easily, so we're going to take that 11 out. You're left with x squared plus 10x plus the space that we're going to work with equals the y minus 271. So step number one in working these kind of questions out is get your problem organized. Get the squared term and all of its components, all the things with x or y, whatever one is squared, on one side of the equation. Step number 2 would be to factor out any value that is in front of the squared term. In order to complete the square, we have to have a single, a 1x squared to work with. That's why we factor that value out. Questions?
Oh, and then when you get 25.
So now we're going to do b over 2 squared, right? So 10 over 2 squared, which is 5 squared, right? So 25 goes here. But I don't write 25 on the other side. What do we do?
Multiply by 11 and that value.
So we have to take this 25, you multiply that by 11. What is 25 times 11?
275.
So plus 275. By the way, unless that value is negative that you factored out, we'll always be adding a value, right? Because 25, even if it had been negative 5 squared, I would still end up with a positive 5. Okay, so now it's about simplifying. We're going to do y plus 4 equals 11 times. Remember, we can do this x, because that was the variable I was looking at here. And then we had a positive 5, so plus 5 squared. And now just get the, if there's a number factored out, make sure to put that on the non-squared side. It's always a multiplication by a reciprocal value. So you got a fraction, it'll be a whole number on the other side. If it's a whole number, it'll be a fraction on the other side, right? So we end up with 1 over 11 times y plus 4 equals x plus 5 all squared. And that's it. For the next section, you have a couple where you're going to be given bits of information about a parabola, and it can be a lot of different things. And you can see essentially numbers 11 through 19 take that form. I would suppose this is the most difficult part for people. Okay, historically, when I've given this test out in the past, this is where people tend to they tend to focus on certain ones, like, oh, I can do these, but I can't do these. So try to do a variety of these so that you can get the method down. On 13, they give you the vertex, which is 1, 9. And we have the focus, which is 1 and 35/4. I'll go ahead and tell you, I always change these fractions, the improper fractions, into a mixed number, because that's going to let me kind of relate that back to the other point that I've been given, or maybe it's a line I've been given. Say, how far away are these points? Well, 4 goes into 35 almost 9 times, right? It's 8 and 3/4. I already know what P is. I already know which direction this graph is going to open up, and to be honest with you, that's all I needed to know. Just by doing that mixed number, I already know that. What's P? Anybody know? Well, P is the distance from the vertex to the focus, or the vertex and to the directrix, whichever way you want to go. So how far? I'm not gonna focus on the value that's the same. The focus and the vertex will always share one coordinate. The other coordinate will be different. The difference in those two coordinates will tell you at least the absolute value of P. I know that how far is 9 to 8 3/4? It's 1/4 away, right? And if that graph, if the focus is below the vertex, it means the graph's not going to open down. If it's above it, it goes up. If it's to the right, it's going to go right. If it's whichever way the focus is from the vertex, that's kind of to tell you which direction the graph is going to open up. And since this is below the vertex, it's going to open up down. I don't need to draw this part, but sometimes it really does kind of help ground you into kind of what you're looking at, right? So here's the vertex, the 1, 9. And there's a very rough sketch. I know that 1 and 8 3/4 will be just underneath that, so the graph is literally going to open up down. That's all I needed to know, because that tells me if it's opening down, we're going to have 4p times y minus k equals x minus h squared. Step number 1 is to figure out which equation you need. There are only 2. If I know it opens up and down, I need the x squared version, right? Because this one is going to open up or down. If the other one we have is 4p times x minus h times or equals y minus k squared. If it opened left and right, then I would use this one, right? So this is the one we're going to go with today because that graph opens down. And so we're really going to plug it all in. By the way, P in this case is equal to negative 1/4 because, well, the distance is 1/4 and the graph is opening downward, right? If it opening upward, I would have to assign the positive value to P, right? If you're working this out, you kind of have to know by yourself how to do it. Now, if you're working with a problem like questions number 16 or 18, where I've given you a point to work with, then P will work itself out and you will find P and it will be whatever it solves out to be. But in this case, I have to choose that value and plug it in. So we're going to say that's 4 times negative 1/4 times y minus 9 equals x minus 1 squared. Simplify that just a little bit. You're going to end up with negative y minus 9 equals x minus 1 squared. And that's it. 14 kind of takes the same idea, but now we're going to be using the directrix. In this case, we have a vertex of -2, -6. The directrix is y equals -41/4. Keep in mind the directrix and the axis of symmetry are both equations. When I ask you for those, I expect to have a y equals and an x equals, whichever one's appropriate. One of them will be x and one of them will be y, because one's a vertical line, one's a horizontal line, and it doesn't matter which way they open. I'll have one of each. Okay, same exact principle. Let me change this into a mixed number, right? Y equals -41/4. That's really -10 and 1/4. I can already tell you that P is a relatively big number. Am I going to compare the -10 and 1/4 to -6 or -2? This one's not quite as clear because it's really far away from that point. Can anybody tell me what P is? Mark, are you going to make it? Yeah? Anybody? What's P?
For which number?
For 14?
17.
It's definitely not 17.
No, it's what's it called? It's -10.25.
Nope. So I'm going to put my vertex down right here, right? So this is -6, -2. if I go all the way down here to negative 10, right, that directrix looks like this. So the parabola is going to be opening upwards because the graph, the parabola here always opens away from the directrix. It's towards the focus and away from the directrix. So we know the graph is going to be going this direction because that's back here. A parabola can never go through its own directrix. All right, you drew it backwards if you do that. So how far is it from that point, right here, to right here?
4.25.
Very good. We know if we say negative 10, I guess 10 1/4, minus a negative, what is it, 6, right? So that gives us negative 4.25. Be careful about the values. Look at your numbers, and you can say, I know the graph's opening upwards, so P has to be positive here. So P is equal to 4 1/4, or 4.25, or you could say 17/4. I don't, whatever you want to do. I'm okay with all of those, as long as it's correct. Since it's opening upwards again, we're going to be using the same formula as we did last time. So we're going to say 4 times positive, I'll say 17/4. Why would I choose that in this case? I can just cancel out the 4, so it makes my math really easy. X minus negative 2 squared. So we end up with 17y plus 6 equals x plus 2 all squared. And really, the way I put in p, if I had used a decimal or anything else, this still would have worked out to be pretty easy to get 17. Number 20. This was a bit of a review. We'll do a lot more of this, and we're starting tomorrow. We're gonna start review for the test. The test is the Tuesday next week. It's just over parabolas and circles. Essentially, I would say if you've done this whole worksheet, you have almost done all the test anyway. There's a little bit more with circles we didn't really do here. This is more about parabolas, but a lot of the same operations happen. And so in 20 you have negative 1/3 x minus 5 equals y plus 6 squared. I'm asked to graph this equation. Graphing it on graph paper is a much easier task. So always have some of that ready to do rather than doing it on just like I'm about to do. Not to mention, when you graph these things, if you have really small values, don't forget that you don't have to make each box 1. You can make each box 2 or 5 or whatever works out for you, right? Just make it easier to graph. Sometimes I'll skip every other box and make each the box worth like 0.5. So even doing 1/4 is not a hard thing to do. Things we're going to need to know. Vertex. What's vertex here? It's always the opposite of your signs, 5, negative 6. The x coordinate comes from the x term, y comes from the y term. That's pretty easy to do. Okay? The next part. Let's go ahead. What is p in this problem?
Would it be 1/12?
We always solve for p using this method. You take the number out in front of that term, whatever it happens to be. If it's a 1, you put a 1. If it's a negative, you put a negative 1. If it's a value, you put the value. In this case, we have a negative 1/3. We're going to multiply by the reciprocal here. That cancels, leaving me with p equals negative 1/12. So really, really small p-value. That's going to allow me to do this. I'm going to go ahead and graph the vertex. So 1, 2, 3, 4, 5. And I'll try to graph this as close to accurate as I can. Now notice that 1/12 is really difficult for me to graph. So get the graph to be generally correct. I'm not going to bring a ruler out and measure it, but I will look at your coordinates to see if your math says you have the right points, right? Your coordinates are going to trump every time the graph. Unless the graph is just terribly, terribly wrong, you'll get the credit for it. Okay, so what I'm going to do is this graph is, which way does it open?
Left.
How do you know?
Because the y is squared.
We know that the y part is squared, and we have a negative value, right? So it's going to open up left, so I can go ahead and just kind of sketch that in. Or not. If I put the vertex down first, I'm going to take my p-value here, and I know that the vertex, or the graph is going to open up this direction, right? So this gives me the direction of where I'm going to place all my values. I know that the focus goes inside it, and just behind it is where this would be my directrix, right? And then if you think about it this way, this is where this is your axis of symmetry. And so I've got the graph drawn. Literally every part of my graph is already finished. Okay. Now sometimes I ask for all of the different elements. Sometimes I only ask for a few. So depending on what's been asked, read the instructions. You may not have to graph everything. Okay. Let's write out the equations now. For the focus. Okay. Notice where the focus is. The focus has the same y value as the axis of symmetry and as the vertex, because it goes through the same horizontal line. So what's the y value of the vertex? -6. So I already got half the focus done. -6 right there. Oh, by the way, isn't that the same as the axis of symmetry? Right, the whole line there? So we could kind of already put that in place. The axis of symmetry is equal to y equals -6. Let's go ahead and finish. What's the coordinate for the x part of the focus? You know the vertex had an x coordinate of 5, right? And I went to the left 1/12. So what is 5 minus 1/12? Right? 5 minus 1/12. I am very much in favor of using mixed numbers in this case, right? It's 4 and 11/12. I don't need I don't need a calculator to do that. I don't need the decimal. In fact, I'd rather probably not have the decimal. It's a lot easier. So I could just say that's 4 and 11/12. Or I could say that's, 48 59/12. However you want to do that, or you could write the decimal. I'm pretty partial to the mixed number. I will tell you this, if I give you multiple choice questions on a test, you are going to see that as an improper fraction. It would say 59/12. Okay, so be prepared for that. Okay, we got one more thing. What is the Directrix equation? Well, in the same idea as we did with this one, the vertex is at 5 here. I went over to the right 1/12. So what is the equation of the Directrix? First of all, is it x equals or y equals? Does it go through the x-axis or the y-axis? It goes through the x-axis, so x equals what number? 5 and 1/12. Or you could say 61/12. Right? Look at it. If you go here, that right there is number 5, and I went over just a little bit for the Directrix, because the Directrix is p to the right of the vertex. Just like the focus is p to the left of the vertex. Right? So you got these differences here and here. So 5 plus 1/12, 5 minus 1/12 gives me the two x coordinates for those values. And that's where we get this.
All you do is just add and subtract the p.
Yes, that is correct. Add and subtract p to the vertex. Everything is focused. No, bad word. Everything is centered on the vertex. We get the focus from using p, and we get the directrix by using p starting at the vertex. And that's how you and this would be essentially it. This question can be a lot of different things. I think I asked you for all 4 elements plus the graph. This is as complicated as this thing can get. I mean, I could give you some weird things, but 1/12 is generally not a very nice value for p. 1/4, I think, is probably the most common value you'll see. Okay, 1/2 can be, or you can have 10, right? That would be even easier. I don't have any fractions to do with it all. Okay, questions? Number 17 looks like it can be really bad, but I think it's just got some ugly fractions. That's really all that you're having to deal with there. 61 over 12, and then the directrix. This is good to do because you don't have the vertex, which is usually one of the things you're given, which makes it a lot easier. Okay, step number 1, as always, is turn them into mixed numbers. That's really going to help me to see a few things. This 61 divided by 12 is 5 and 1/12, and 59 is 4 and 11/12. So can anybody see what's the number right in between 5 and 1/12 and 4 and 11/12?
1/12.
Is it just 5 at point 0? Isn't 5 right in between those two things? Yes?
Oh, yeah. 5.
So guess what the vertex is?
5.
The vertex in this problem is going to be -10 because the y values are changing. That's gonna the y vertex is going to be just 5. So let's draw it first. That really helps to illustrate it. I'm going to go ahead and label, so -10 on the x is here, and we'll go down to, here's -5. 5 and a little bit more is the focus, so we'll put that down here. And then I have to go back up just a little bit to write the directrix. So remember, the vertex is halfway in between the vertex, or in between the directrix and the focus. So if the directrix is here and the focus is here, then that means the vertex is halfway. And I can see that here. I've added a 12th to 5 and I subtracted a 12th to 5 to get the two different values, right? So we know that the vertex, well, it has to be, -10, right? Because it's all on that same line right there, -10 and -5. Because it's halfway in between the directrix and the focus. We know that P is this graph is going to be opening down, is -1/12. We noticed it was 12 because it's 2/12 from the focus to the directrix, right? That's twice P. So half of that is 1/12. It's opening down, so I know that it's negative. We're also going to write out it's going to be 4P times y minus k, not squared, equals x minus h squared. We know that it's x squared because it's going down. We know that P is negative because it's going down, and I can solve it this way. So 4 times -1/12 equals, let's see, y minus -5. Oh, no, not equals. Yeah. It's times. Equals here, and then it's going to be x minus -10 squared. Then we can multiply this out. You're going to get -1/3 times y plus 5 equals x plus 10 squared. And that ends up giving you the full equation. I would consider this one on the more difficult side of things. Okay? So if you get something like this, you can get through this. I didn't give you the vertex. I mean, let's be honest. If I gave you the vertex and you can figure out which way the graph opens up, that's almost the whole equation right there. The only thing you don't have is P. Okay, now I'm almost out of time. If you haven't done 18 or 16, remember 18, you have to look at the graph and you have to find the exact point that the graph goes through. Okay? So you can tell if you look on number 18, it's got the graph goes through 0.25 and 0.5. All right, that would be the x and y coordinates I'm going to plug in. I'm going to work that out just like 16. You're going to plug in the point as x and y, and you're going to use the h and k from your point, plug all that stuff in, and solve it for p, and then just plug it back into the equation. I hope this helps. If you have any questions, you can email me.